much time, and I hope the coffee was strong. There are 2 talks in a row by philosophers. I don't know what happened to SOGETI. Now, allow me a simplification to begin with. There are 3 kinds of people interested in philosophy. The very young, who ask, why I was born, Dad? The very old, who ask, what's going to happen once I'm dead? And the very wise in the middle. Anyone else is too busy, okay? So, and since I see the crowd around here, I see a wise crowd, no children, no very old. So welcome to a moment of wisdom in the afternoon. Now, I shall tell you a little bit more about the second half of the title, the problem. But let me introduce this with just a little joke. You walk into a restaurant and there's a wonderful menu, lots of things you can choose from. That's a nice problem to have. You walk into a bank and you know what? SOGETI decided to give you a present. There's so much more money there. That's a nice problem to have. How do I invest all this money? So that's the kind of problems that I tell my students, that's a nice problem to have. You want to be in that particular position. You don't want to have the other kind of problem, the nasty problem. So in the end, I will tell you more about this kind of problem, the nice problem to have. But before, and in order to get there, here's the map of the talk. And just in case you thought this is something new, it isn't. I mean, it's economist level. So I'd like to introduce you to 3 ideas, and that's what philosophers do. They shape and sell ideas. One about time, one about space, one about agents. And that's the first half. Once we have that kind of framework, time, space, agents, then I like to talk about big data, how we got them in the first place, what kind of challenges we have, and why those challenges are not very interesting. Those are not the nice problem to have. And why the nice problem to have has a difficult solution. A bit of conclusion, just in case you forgot, after half an hour, 28 minutes, there is a philosopher talking, but I won't tell you anymore, you will see. So, the 3 ideas. There are some philosophers here, forgive me for this big canvas. You pick up a textbook and in archaeology, and that textbook tells you that the very concept of prehistory is linked to information and communication technology. Is what happens to human life on this planet before that culture, society, has a way of recording its memories. That's prehistory. So there are some people in the middle of the Amazonian forest who are living in prehistory as we speak. Then we moved about 6,000 years ago to history. History is the long, long term where you have ways of recording your past. This is when the individual and social well-being starts being connected to ICTs. Well, we have recently, that's the suggestion from a philosopher, moved to some kind of a hyper-history. Is when the ICTs not only are there, but it's what we rely on in order to improve our well-being. So 6,000 years are coming to a conclusion. God knows what's going to happen for the next 6,000. During those 6,000 years, big data was always an issue. Of course, it was a small issue, big data. There was a time when erasing your hard disk meant using a hammer to smash your tablets, those tablets. And it was a time when saving your data meant baking the tablets. We have, or at least we used to have, after the war, this is no longer the case, about 500,000 of those tablets. Those are the ones that we wanted to save. And guess what? There are no love letters there. It's all about business and administration. People like you, basically, so many years ago. So in this case, we have seen a progression of big data moving quickly from those tablets all the way down to here. And that's the first idea. So in terms of time, we're living in a special moment where we're moving from a dependency, interconnection with recording systems, to a stage where we are delegating to new systems the processing of our data. I promised space, and here we are. If you like a shortcut, call it infosphere. Now, for about 50 years, especially philosophers, but also computer scientists, and down the road, the ICTs guys, have been discussing about the nature of AI. They said, well, is it not? Does it not happen? What will be the future when computers will be smarter than us? Oh, just wait. No, my computer can't recognize the print anyway. What has really happened while we were discussing about the intelligence or non-intelligence of those machines is that instead of succeeding in making the machines working in our environment, we transform the environment in such a way as to make sure that the environment is such that those machines can work within. If you find this concept slightly confusing, here is an industrial example. Envelope is the 3D space where an industrial robot is successfully active. Car makers know exactly what we're talking about. A car maker builds the whole building around the robots. It doesn't unleash robots, no, in a building. So we've been enveloping the world without knowing it for a long while. It's like on your left, building a whole environment around two stupid little things that go round and round with a lot of water. If my wife were to see me washing the dishes that way, she would be worried. Now, the silly thing, the stupid idea, is in the middle. It's, oh, let's build a robot that does exactly what I do when I do the dishes, because, gentlemen, I do the dishes home. They're very smart. Smarter than the left is the top right. Let's get a robot that can put the dishes inside the dishwasher. And that's the one I'm looking for. So in this particular case, if you think, oh, that's a great philosophical idea, but come on, get real. Here is how real it gets. Almost 20% of Europeans have been connected online wirelessly while not being at home or in the office. Where were they? In a space which has been transformed to make sure that they can work within it. There's something about this which means that we can use all this big data for a purpose. Maybe there's more time about question and answer later, but there's something positively said when big data, and you find there a diagram which says bottom, little dark line at the bottom is the negative impact that all this data are having on our environment. After all, you need energy. The top larger chunk, green, is how much they are helping us to save the environment. So there's a new trend in green technologies that can transform big green data into something very helpful. But let's go back to what I was saying before. Remember, the environment, we're transforming it, we can actually save it through big data, but what is happening? Again, space. Well, grandma used to work inside a computer. Her daughter walked out. The computer was in front of her. Her niece is back inside. The infosphere is now around her, and that's her environment. Third idea. So we have a bit of time, a bit of space. Now the agents. What has happened moving through hyperhistory, walking into an infosphere? What about us? Again, simplifications, and the philosophers among us will forgive me. You pick up knowledge, science, technology, and they basically have two ways of making a difference to how we handle the world. One is, it's about the world. They tell us more about how the planets work, or how you can build things, and so on. The other one is about us. And I'm not talking about psychology or anthropology. I'm talking about normal science that, by telling us something about the universe, fires back and tells us something indirectly about ourselves. Now, this idea is not new. There have been 3 previous scientific revolutions, Copernicus, Darwin, Freud, that by making a difference to how we understood the universe, the animal kingdom, our mental life, they actually told something about ourselves. They told us, first, that we were no longer at the center of the universe. Oops, that's so sad. we thought, well, at least we are the best at the particular game called life. We are on top of that game. And then Darwin came and said, sorry, you have to give up that second trench too. You're not at the center of life either. Says, oh, well, you know what? At least we are the thinking animals. We are at the center of the rational game. And then Freud came and says, well, there's a lot about your rationality you don't know. So that trench also has to go. And my suggestion is that we are undergoing, and that's the third idea, a fourth revolution. Because we thought, well, at least as agents, with some rationality, with some information, with some ability to choose, we are unique. We'll try to explain that to the sort of robo software online next time you try to get your bank giving you a loan. So the fourth revolution, which you may attribute to Alan Turing, since it's also the anniversary year, is showing us that we are more connected, we are sharing the environment with other agents of all different kinds, biological, engineered, and therefore, again, it's a bit humbling. It doesn't mean that we're not special, but we must be special in a different way than the 4 ways we saw in the past. So this is the first part. 3 ideas, how history has changed, how space has changed, and how we have changed our self-understanding in their time, in their space. All this, of course, is connected to well-known facts, and this and the next slide are just there to remind you about things that you know, and I know that you know, so do not allow me to offend your intelligence. This is the usual Moore's law. It's just interesting to see how big that is. In 40 years, and I picked up 40, so 2010, because there will be more references to 2010, we moved so quickly, and there's been a 1 million-fold power in our capacities to handle data. A genius, Steve Jobs, understood that that power was not meant to crunch data, it was meant to have cool interfaces, but that's another story. Meanwhile, that's another curve. That's how much it cost crunching all those data, and it costs less and less. Now, if you look very up there, that's something I had to check on Wikipedia. It's $100 trillion for the equivalent of what you can do with an iPad 2 today. Now, just to have some figures, because unless you are in the US Army, you don't understand what 100 trillion is. That's my experience, at least. No, talk to generously, of course, that's my next tank. Well, Qatar, which is 57 out of 190 countries in terms of GDP, in 2010 had $90 trillion of GDP. So the Qatar budget would not have allowed you to buy the processing power 50 years ago that today you have in your hands with an iPad 2, and that's also old. So those are some figures that make us think in terms of what kind of capacities we have. Now, of course, that has generated, as we heard this morning, an immense amount of data. And again, just some figures to qualify how immense that is. Well, 1 exabyte is 50,000 years of DVD. It's plenty of Sundays there. And it's a bit of a joke. We don't know. Nobody really knows. But even if we are wrong by 100%, 5 exabytes is all the words ever spoken. Your wife included. So, yes, you see, that's a lot of data. Oh, I'm going to be punished for that, I know. Yes. That's a lot of data that it's nice to have. It really is nice to have. Who said that that is a problem? The problem is how to use those data, is not to have them. That's why big data can do a lot of things for you. That's a really quick summary, and I don't have to explain this slide in too many details to this audience. If you were philosophers, I would. So let me just be rather quick. You can improve what you're doing with your company. You can tailor your products down to the last customer, if possible. You can predict what's going to happen to your products. Above all, something that some people forget, you can simulate what might happen to your products. You don't have to do it, get it wrong, and redo it. You can run scenarios as if with your data, well, if your IT department is good enough. You can make better decisions. No, more data, more information, better decisions. And of course, bottom line, which is the real issue, you can innovate. And that's where the pressure comes, because you and I are not the only ones running this particular game. Someone else is going to innovate at the same time the same products. That's why the data, not having them, but using them properly becomes a problem. Because if someone else uses them better, more quickly than you, then that is the trouble. So big data can do a lot for you. They also present a number of challenges, and again, this is something that you pick up from ordinary literature, so it's just a quick reminder. You have a problem of acquiring those data and storing those data. They have a physical nature that, of course, comes with constraints. You have a problem about quality of those data. What if there's a lot of junk in it? And usability, because even if there's a lot of them, because they are unstructured, that's not necessarily easy to handle. And of course, the usual headaches for some CEOs, the security, the safety. And suppose all that is solved. Well, you need to have access quickly, in real time, and so on. And then you need to have a cool department that does all the fancy magic with the analytics. And finally, you think you've done, and there's a legal problem somewhere, or an ethical issue about privacy, and so on. And all that raises costs. So these are all challenges. I'm not calling them problems, because these are technical issues that, one way or another, businessmen, women have been dealing with in the past. This is just new versions of something that has been around for a while. Let me just point out one issue, if I can get this thing right. Someone spoke about the need for forgetting. Well, forgetting is not a right, it's a destiny. We will all be forgotten, trust me. So unless you're Julius Caesar, you're not running any risk. The problem is how quickly. It's not whether you're going to be forgotten. I will, you will, but how quickly and in which context? Well, there is a lot of forgetfulness already since 2007. Again, this is economist material, so you don't have to be a scientist. It's something you pick up in The Economist, which will remind you that since 2007, we have been unable to store all the data we want, and it's getting worse. So again, the problem is not, oh, I saved everything, let me see what the analytics looks like. The problem is, boss, we have run out of space. Do we buy more, or do we erase something? It's like your emails with your inbox. Which emails really want you keep? All of them until your hard drive is full? Probably not. All the pictures you ever taken? Probably not. So the problem in the past, good old days, was how to save stuff. Because you had only that amount of parchment, only that amount of paper. Today, the problem is, okay, what do I erase? Because everything automatically stays around, at least for a while. And this is just one chapter in that whole list. But as I said, these are challenges that I think good business can solve, can tackle. This is the end of the second part. This is when we have seen what big data are, why they are interesting and valuable, and what challenges they present. They actually, as I said before, seem to represent something like a resource that we want to be able to use properly. So what's the problem with big data? Why the big fuss? If everything is all fine, and if all we need to do is just be better at what we've been doing for a long while, is there real novelty? Well, here's a suggestion for the third and last part of the talk. The problem with big data is, and I learned this from the best in the morning, you need to be a little bit of advertisement, is small patterns. The fact that we can accumulate so much data, not to do the same that we used to do in the past. If some people don't like a particular car, You don't need lots of data. I mean, they just don't like it, you see it, that's the end of it. But if they don't like it for a particular color, that's a small pattern that you cannot see unless you have lots of data. So the problem, the substantial, the philosophical problem behind big data is how many small patterns can I find with all this wealth of resources? Because all those data points there, they don't really show a picture. And if you have all those data points, but don't put them together, you don't see the telephone. You see the telephone only if you can connect the dots. And you connect the dots only if you have lots of dots. And to connect the dots properly, you need analytics. And that's the problem with big data. How do I connect the dots? Where are the dots that are really relevant? What are the small patterns that I want to be able to identify in order to, at the end of the day, innovate better than my competitor? Now, small patterns come with problems, difficulties. They might be insignificant. This is half a sort of quotation from a joke about advertisement. But half of your data is junk. It's just you don't know which half. So you don't know which half you want to erase. Small patterns may be significant only if properly aggregated. So you might have your card, shopping suggestions, and so on. The problem is, and here's again, trivial example, you should have encountered already, but if you haven't, here's a quick presentation. You might be a company like Target, which puts together 25 products so that it can identify the profile of a particular customer. In this particular case, is pregnancy. So if you buy those 25 products in a certain order, and they can analyze those data and send coupons timed to specific stages of, well, the pregnancy of the person in question. The trouble is that they did that with a very young lady who hadn't informed her parents yet. And she started getting all these coupons home. And the parents started getting really concerned. They complained to Target, they got an explanation, big legal case. So, again, the aggregation doesn't come without cost. The other issue with small data is that they might be significant only if compared. Not only half of it is rubbish, not only you have to put them together, but you also have to be able to compare them. And, well, my wife and I were in Brazil, they cloned our credit cards, we went back to UK, the bank, a huge bank, a bank which can work both in the UK and in Brazil, which shortens the list, was unable to discover that the same card was being used at the same time in two different corners of the continent, of the world. They reimbursed the whole amount, stolen, of course. That's what big data should be doing for you if you know how to use it. And finally, the most difficult problem. Sometimes small patterns may be significant only because they are not there. And this is a classic piece of Sherlock Holmes. Sherlock Holmes solves this particular case because of the silence of the dog. The dog in this particular story should have barked. It didn't. And that was significant. So some of the data you have are significant for what they're not saying. Now, small patterns, significant when they are not there, only if aggregated, only if compared. That is the kind of problem you have with big data. It's a problem that can be summarized, and we're coming to the end of this presentation, in 3 steps. What you want is information. And a quick definition of information is questions plus answers. Take the following piece of information. The capital of France is Paris. That's a typical first-year logic introductory course. That's why philosophers are so smart. And that piece of information gets analyzed into, is the capital of France Paris? Question mark, yes. The question goes on one hand, contains all the good stuff. The yes is just one bit of information that you find in the database. What you want is those two things together. You want to have the whole thing. You want to have the capital of France is Paris. To do the blue stuff at the bottom. What you have, and those are more data on data, is a lot of data. Consider an infinite, endless amount of yes and no's to all your questions. Your question about the capital of France, or your next budget, whether Greece will or will not stay in the European Union, whether the euro will or will not make it, and so on. Somewhere, somehow, you hope that there is a big database which, if properly analyzed, could provide the answers, the yes and no's to those questions. So what is, ultimately, finally, intelligently, unfortunately, the real problem about big data? Is the questions. That's what we need, and that's what we don't have. And that's what makes a difference between a fantastic company and a disaster. Someone somewhere asks the right questions. If you have a student who moves from being an undergraduate to a graduate student, moves from learning to producing science, the first and most difficult thing to teach to that student is a taste for good questions. You have to teach that person to ask the smart, intelligent questions. That's half of the job, because then anyone, or almost anyone, with a good brain can find the answers. You look at the history of some scientists and you will see that the smartest inventions, the smartest discoveries were prompted by the smartest questions. That's the problem with big data, which comes quite handy, because I said I want to remind you that in the end this is a philosophy talk. So what happens if we look back and the history, the space, the agents? Well, we're just back to some classic advice from a classic philosopher, Plato, Cratylus. A knower is a man who knows how to ask and answer questions. Not just answer questions, that's just a good student. Someone who knows is someone who knows how to ask the right questions. If you know how to ask the right questions to big data, you'll be successful. If not, well, history will decide. Thank you so much.